Picking up where we left off yesterday, we still need to talk about a mid-segment. A mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. A picture of that is exactly what it sounds like. You have a triangle. You have midpoints on two sides. If those are midpoints, that means these pieces are congruent to each other. The mid segment is the piece that connects those two midpoints. So that is the mid segment. Connects the midpoints of two sides of a triangle. How many mid-segments do you think we could draw in a triangle? Three. Okay, we have got one there. We could make another one that goes between these two sides. We could make a third one that goes between those two sides. You can have three mid-segments. The mid-segment theorem. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. So we'll get this diagram filled in to show what that means. What segment in this diagram is the mid segment? DE. The segment here is our mid segment. So this theorem is stating that the segment connecting the midpoints of two sides, that whole thing is the definition of a mid segment. So the mid segment is parallel to the third side. So that means that DE is parallel to which side? What side does it not touch? AC. Okay, so if you want, you could mark that in your diagram using the little triangles. Those two sides are going to be parallel to each other. And is half as long. So that means that the length of DE is half the length of which side? AC still the side that it does not touch. So the length of DE, or the distance between D and E, is half that of AC. That is only true if these points D and E are midpoints of that side. So if we don't know that D and E are midpoints, or that these pieces on the sides are congruent to each other, then we don't know this stuff to be true. This only works when we have a mid-segment. These examples should go fairly quickly. The mid-segment theorem is pretty straightforward. How do we know that we have a mid-segment on number 5? Or on, it's your number 7. I'll update that. How do we know that that's a mid-segment? The mid-segment theorem doesn't tell us that that is a mid-segment. The mid-segment theorem tells us if we have a mid-segment, what we know about it. Good. We got these two pieces are congruent. That means that this must be a midpoint. Same thing on the other side. If those two pieces are congruent, then that's got to be a midpoint. So if the line connects two midpoints, that's how we know we have a mid-segment. If we know that we have a mid-segment, the mid-segment is half as long as the third side. So what's the third side? Nope. The third side, the side that the mid-segment doesn't touch. 42. So the mid-segment is X. So the mid-segment equals half of the side that it doesn't touch. Half of 42 is 21.
Quick question.
Yes.
Do you do mental math, or you want us to do x equals a half
I'd be okay with you just going straight to the answer on these.
Okay.
I believe that you can take half of a number in your head. What I want you to be careful on is when we go the other way. So on number 8 last year, a lot of people told me the answer was 3. Why is 3 incorrect? Okay, it's bigger. The one on the outside of the triangle is bigger. The mid-segment is half as long as the side it doesn't touch. So if we were to set it up with a formula or an equation, 6 is half of y. So then some of you have already told me, what is y going to have to be? 12. Okay, we could multiply both sides by 2 to show that. Again, I'm not requiring it. If you were to be able to look at the diagram and give me the answer y equals 12 right away, that's fine. I just want you to be aware that you're not always taking half of whatever number you see. Sometimes you have to double it to go the other way. Also on number 8, how did we know that we had a mid-segment? What's congruent? The pieces of both sides are congruent. So 7 and 7, that means we got a midpoint here. 5 and 5, that means we got a midpoint there. So remember to only use this if you know that you have a mid-segment. You will see other triangles like we've seen before, even earlier in these notes, that look similar, but they don't have a mid-segment, so we can't use that theorem. If it's not a mid-segment, that theorem doesn't work.